FP1 numerical methods, example 6. This is our first example on the third method. We've done interval bisection and we've done linear interpolation. This is the third method called Newton-Raphson. This is the formula. It's a recurrence relation, which you will have studied in C1. You'll notice the use of f dash here, which means the derivative of f of x. You don't have to memorise this formula. It's in the formula book, so just make sure you're familiar with where it is. So first thing we do, remember that the equation has to equal 0 that we're dealing with. So f of x, in this case, would be x to the 4 plus x squared minus 80. So in other words, I'm rearranging this so that it equals 0. Okay. So we've got to use the Newton-Raphson process to find the root, which is near to x equals 3, and we've got to get it to 2 decimal places. So I'll just have 2 or 3 goes at the iteration just to show what's going on. In an exam, they tell you exactly how many times to apply the method. So first thing we need to do is work out f dash of x. Differentiating this, we get 4x cubed plus 2x. So our iterative formula will look like this. We'll have f of xn on the top. So that's xn squared minus 80. And then on the denominator we have f dash. So that's 4xn cubed plus 2 times xn. I'll put brackets around those just so it's clearer. So our first approximation, which sometimes we call x1, sometimes we call it x0. The first approximation is 3. So our second approximation, this would be 3. And then you're going to have 3 to the power of 4 plus 3 squared minus 80. And on the bottom we'll have 4 times 3 cubed. Remember to cube it first. And then multiply it by 4 and then 2 times 3. So work all that out. Pause the video if you want to at this stage. And I got 2.9122. So just check that you can get that on your calculator. Now, store this value in your memory of your calculator. So store it as A, because then for x3, all you're going to do is you're going to do A minus A to the 4 plus A squared minus 80 divided by 4 lots of A cubed plus 2 lots of A. So in other words, you're just going to keep using the fact that A is stored in the memory. So if you have a go at that, and that works out to be 2.90831. That will be your value for the next iteration, and then you can just keep going and going. So in an exam, they normally ask you just to do 2 iterations. So we've done that now. And so to 2 decimal places, you'll see we've got 2.91 here. It's still 2.91. So the root is 2.91 to 2 decimal places.